This potty bench is going to be outside, so I needed to find a wood that could withstand being out in the elements. The customer and I settled on white oak. I figured up how many board feet I would need for the project and added a 20% buffer to be safe, and then headed to the hardwood dealer. This bench is built completely out of solid wood except for the top, which is stainless steel over an MDO plywood subtop. Outside of cutting boards, I haven't really worked with solid wood, and there are definitely some different challenges compared to working with plywood. The first of those challenges I faced was laying out all the parts on the boards. I measured all the different boards I bought and then took those into Fusion 360 and laid out all the different parts on each board. With all the boards being different sizes, there was a lot of trial and error. I also used up every bit of that 20% buffer I bought. Once all of the parts were laid out, I used a jigsaw to cut the boards into more manageable sizes. As I cut down the boards, I labeled each piece with whichever parts were in that piece. I then went to the bandsaw and miter saw to break down the pieces, and they were ready for milling at the joiner and planer. Let's talk a little bit about the milling process. This being my first project with solid wood, I was kind of taken aback by how long this process actually took, and it's something to note for future projects. Before sending anything through the joiner or planer, I marked the direction of the grain on each piece. I then jointed one side, planed the other side, and then back to the joiner to joint one edge. I do the edge last so I can ensure that I get the grain direction oriented properly. On the first round of milling, I left everything about 1/8 of an inch oversized and let them rest overnight. I only milled parts to their final dimensions when I was ready to start assembling those parts. Also, I made sure to take off equal amounts of material from each side. This helps ensure that each of the faces have similar moisture content, which limits the amount of movement in the parts. You can assume I followed these steps throughout the project if it's not shown later in the video. I can now start assembly, and the first parts to assemble were the sides, so I cut down the parts to the required size to table saw. Each side is made up of 2 legs, a frame and panel at the top, and a stretcher at the bottom. The frame and panel is a simple stile and rail assembly, but I made this way more complicated than needed. I originally wanted a 3/4 inch panel centered in a 1.5 inch frame. To try and save material, I decided to do a 1/4 inch panel. That would have been fine if I still centered the panel, but I wanted a smaller recess, so I offset the panel to one side. Each stile and rail needed a 1/4 inch groove, which was very easy to cut using the dado blade on my table saw. I then needed to cut a tongue on each end of each rail, and this is where things got sideways. Normally this is very easy using a table saw. You just set the blade height a little low and then flip the piece back and forth, nibbling off a bit each time, which allows you to sneak up on a good fit. Because the tongue was offset, I had to try and get one side perfect and then flip the piece, change the height of the blade, and get that side perfect. After a couple fails, I decided to try to utilize the router table in the process. I set the table saw for one side and the router table for the other and just went back and forth. This was far from efficient, but I was able to make it work. However, once I started having issues, it would have been way smarter to just get more material and do it the way I'd originally planned. FYI, the plans show the original 3/4 inch panel design, so you won't have to deal with any of this if you are purchasing the plans. Speaking of the plans, there is a link in the description if you're interested, as well as links to all of the tools and hardware used on this potting bench. I started assembly of the frame and panels, and to strengthen them up, I decided to use dominoes on the back side of the frame. The domino is used a lot on this project, and I know not everyone has access to a domino, but outside of this particular joint, dowels can be used in place of dominoes. In some cases, dowels would have been much easier than dominoes. Dowels are very easy to center on stock. Dominoes reference from one side, so you have to really pay attention to the faces you're referencing, or things will get sideways in a hurry, which is what happened to me in a couple of instances. I got the frames dry assembled and checked for square, and all looked good, so I moved on to making the panels. I glued up a few pieces that I could resaw into the 2 panels. The glue I used on this project was Titebond polyurethane glue, and this was by far the most challenging aspect of this project. I needed a glue that 1, was good for outdoor projects, and 2, as you'll see later in the video, had a long open time. Polyglue seemed to fit the bill, but it was an absolute mess, which you'll see over and over in this video. I could have saved myself a lot of headaches by using something like Titebond 3 for the parts that didn't need a long open time and epoxy for the others, but I did not think of that during this project. Anyway, you'll see the mess that ensues later on in the video. I also get into more detail about the glue situation in the build article, which is linked below. After resawing the panels, I jointed and planed them and then cut them to size at the table saw, and it was time to glue up the subassemblies. When you have panels like this made from solid wood, they are going to expand and contract, especially being outdoors, so it's best to leave them undersized. To keep them from moving around in the frame, I use space balls.
What?
These are just little rubber balls that allow flex of the panel but keep them from moving around in the frame. These are really handy if you are making raised panel doors or drawer fronts because it keeps the panel centered in the frame. I also applied the finish to the panels before the glue up off camera. I'll get more into the finishing process at the end of the video. While those were curing, I moved on to making the front frame, which is made up of 1.5 by 1.5 stock and has 3 openings for the drawers. I again used dominoes for the joinery. One of the few things about this polyurethane glue that I did like is that it is not soaked up by the wood, so the joints slip together really nicely. Unfortunately, that also means that they come apart very easily, so it can be a little cumbersome clamping everything up. I let the front frame and the side frame and panels cure overnight, and the next evening I started to become familiar with the pitfalls of using polyurethane glue. It seems like no matter how little I used, I got an insane amount of squeeze out. For this frame, it wasn't a major issue because only the front is going to be visible. I knocked off the bulk of it with a chisel and then sanded down the rest. I moved on to finishing up the rest of the parts for the sides. The legs and bottom stretcher were milled to their final thickness and then cut to length on my crosscut sled. All of these parts are attached with dominoes, so I cut all of the mortises I needed in the legs, the stretchers, and the frame and panel. I then did a dry assembly to make sure everything was square, and in a somewhat out of character moment for me, they were dead on. Before gluing up all the sides, I wanted to do a dry assembly of the whole base, so I needed to make the back and the long bottom stretchers. For the back, I just glued up some offcuts since its looks don't really matter, and the bottom stretchers were milled to their final thickness and cut to length with the miter saw. I then needed to cut the domino mortises in the back, the stretchers, the front frame, and finally the legs of the side assembly. The dry assembly went well, so I sanded all the parts of the frame to 150 and then turned my attention to gluing up the sides. After the glue debacle on the front frame, I thought it would be a good idea to take preemptive measures and wipe down any squeeze out with mineral spirits. This worked initially. This polyurethane glue just keeps squeezing out, so even after I cleaned it up and let it sit to cure, just more squeeze out just kept on coming. The big problem is in the corners, and I found my best approach was using a card scraper. Unfortunately, I am not that great, some may even say average, at sharpening my scrapers, so while a noble effort, this didn't really fix the issue completely. As you can see here, I made a mistake in my domino location by referencing the wrong side, so I ended up filling the mistakes by gluing in dominoes and then cutting and sanding them flush. At this point, I had the sides and front assembled and the rest of the parts ready to glue up the base. As I mentioned earlier, the poly glue can push apart the joints, so it's going to be a difficult glue up. I enlisted the help of my friend Luke for an extra set of hands. This glue also makes a giant mess. It has the consistency of honey, so it just gets all over the place. All of the blue painter's tape you see is an attempt to mitigate the poly glue squeeze out problem, and that just did not work. This is the step where I really needed that long open time. There were about 20 dominoes in this glue up, which meant there were 40 mortises that I had to spread glue into, which took a fair bit of time. The whole glue up took about 30 to 45 minutes. I let the glue cure overnight and took the clamps off the next evening and started to inspect the joints and remove the blue tape. The tape basically just fused with the glue, so now not only did I have a ton of Squeezeout to address, but it was all mixed in with blue painter's tape. There were a couple of spots where the Squeezeout wasn't too bad, so the tape trick did work, but the majority was a mess. I assaulted all the joints with card scrapers, sanding blocks, and chisels, and finally got it somewhat respectable. Moving on to the drawers. I milled up the parts for the drawer boxes and glued up the drawer bottoms. Once those were dry, I used my drum sander to get them to their final thickness as they wouldn't fit in my planer. I then used my table saw to cut them to their final length and width. For the drawer boxes, I decided to go with reinforced rabbets. The drawer sides and backs are 3/4 of an inch thick, so I used a dado blade to cut a 3/8 of an inch by 3/4 inch rabbet into each end of the drawer sides. I then used the dado blade to cut a 3/8 inch groove spaced a 1/2 inch up from the bottom for the drawer bottoms. Before assembling the boxes, I needed to cut out a notch on the backs for the drawer slides. I then sent all the drawer parts through the drum sander and then did a quick sanding with my handheld sander, and it was time to assemble the drawers. I applied glue to the rabbets on the sides and the ends of the fronts and backs. By this time in the project, I had figured out that a little of this poly glue goes a long way, so I brushed on a very light coating on the joints. This gave very little squeeze out, so all in all, the drawers went together much more smoothly than the previous parts. The bottoms float in the drawers, so no glue in the grooves. I clamped up the drawers to hold everything in place while I drilled and countersunk some 1 1/4 inch screws to reinforce the rabbets. The rabbets weren't perfect, so I cleaned them up a bit by using a flush trim bit in the router table. I then gave the boxes a final sanding. I like to sand as I go for a couple reasons. One, it's a lot easier to sand parts before they're glued up, and two, I really loathe sanding, and so this breaks it up a bit and saves me from an hours-long sanding session at the end of the project. I turned my attention to the drawer slides by first breaking down the parts I needed at the miter and table saw. The slides are 3/4 of an inch thick and rest on the front frame and a cleat attached to the back. I only have a 1/2 inch recess on my drawers, so I needed to cut a notch in the front and back of the slides, which I did at the table saw. I tested out the slides by putting them in place and then positioning the drawers. Everything worked okay, so I attached them to the cleats and the frame with 1 1/4 screws. It was a tight fit, and this right angle attachment was perfect for drilling and driving the screws. The drawer fronts are shaker style, so making them is much like the side panels I made earlier, except this time it was much easier because the tongue and groove were centered in the stiles and rails. However, I still made a mistake, which we'll get to in a second. I first cut the grooves. Using my regular blade, I cut a groove in the center of the piece and then flipped the piece around and cut the groove again. I then adjusted the fence out in very small increments and continued to cut the groove while flipping the piece back and forth until I had a perfect 1/4 inch groove. I then used the dado blade and my miter gauge to cut the tongues. This was a mistake. I should have cut the tongues first and then cut the grooves. That way I could sneak up on the fit. I could still sneak up on the fit with my approach, but I think it's a lot easier the other way around. I actually cut the first tongue too small and had to CA glue a little strip onto it to make it fit okay. The panels needed to fit into the grooves, but they also needed to sit flush with the back of the stiles and rails, so I cut a rabbet around the outside of the panels. I can now glue up the drawer fronts. Like the side panels, I used spaceballs to center the panels and allow them to expand and contract a bit. I then brushed on a very light amount of poly glue, assembled the parts, and put them in clamps. I used some small clamps to help me flush up the stiles and rails. I then checked for square and put them aside while I focused on the top. The top is made up of two parts, an MDO plywood subtop and a stainless steel cover that slides on over the subtop. I cut the top to length and rough cut to width with the track saw and then cut it to final width at the table saw. The subtop needs to attach to the base, and I went with tabletop Z-clips for the fasteners. These Z-clips fit into slots on the base and then are screwed into the top. This allows for wood movement since the clips aren't mechanically fastened to the base. After cutting the subtop to size, I used the domino to cut the slots. You can also cut these slots with a biscuit joiner or even by just drilling a bunch of holes next to each other. You don't need a lot of precision here, just make sure they are spaced down correctly. The base was then placed upside down on the top so I could easily line it up and drive in the screws. The top was then removed so I could start building the backsplash and the hutch. I focused on the backsplash first. Again, I'm using the domino here for all the joinery, but this could be done with dowels or a combination of dowels and pocket screws. I cut mortises around the sides and back of the plywood subtop. Layout of the dominoes here was critical, so I really took my time to make sure everything was matched up correctly. I then cut the mortises in the backsplash and side splash parts, ran them through the drum sander, and then did a final sanding with the orbital sander. Once everything was sanded down, I moved on to more fun with the poly glue. I had a decent handle on Squeezeout at this point, but any amount I did have was very problematic when it came to sanding. And just to let you know, I did try to clean up the Squeezeout as I was doing the glue ups, but even if you cleaned it, it just came back 20 minutes later. So it was just a constant issue I was having to deal with. With the top assembly finished, I cut all of the hutch parts to size and then cut all of the required dominoes. The hutch is made up of two sides with an upper shelf and back. The hutch is attached to the side splash with screws so it could be easily removed for transport. I pre-drilled all the holes for the screws on the drill press and then cut some more dominoes. Before glue up, I sanded down all of the parts while sanding was easy. During the glue up, I again used way too much poly glue and was left with all kinds of Squeezeout. Moving now to the slats. Each slat had two screws at each end. To make sure all of the screws were in the exact same position, I made a little jig that allowed me to accurately and repeatedly mark the spots for the screws with a brad point bit. I then took the slats over to the drill press and drilled and countersunk holes. The slats at the end needed notches cut into them so they could fit around the legs, which I took care of on my bandsaw. I clamped the two slats at the ends in place and then used some spacers I made to position the rest of the slats. The spacers were just a little bit too small, so I used a folded up piece of paper to close the gap. Once the spacing was correct, I screwed down the end slats. The remaining slats needed to be clamped in place so I could drill the holes into the stretchers. I thought this was going to take every one of the clamps I had, but I wasn't sure, so I figured I'd ask Gary Ullman. Hey Gary, how many clamps do you think I'll need? Everyone! Okay, that's what I thought. Thanks, Gary. Each slat was screwed into place through the pre-drilled holes with 1 1/4 screws. Before moving on to finishing, I wanted to install some leg levelers. I used a dowel jig to drill a hole in the center of each leg and then inserted a T-nut and threaded in some levelers I picked up at Home Depot. This will help prevent the legs from absorbing water. Time for finish. I removed the slats and sent them to the drum sander and finished them with the orbital sander. I also hit the rest of the bench with one final quick sanding to 150. I decided to go with Rubio Monocoat's hybrid wood protector. It's a one coat finish, so that seemed easy. They recommend cleaning the wood with their cleaner before finishing. Given the cost of the cleaner, I can see why they push it. However, other folks seem to get by just by using mineral spirits. Once everything was cleaned, it was time to finish. I wiped on the finish with t-shirt rags. This application isn't listed on their site or on the can, but I emailed Rubio and asked if this was a good way to apply the finish, and they said you can roll it on, brush it on, wipe it, whatever really. You just need to keep a wet edge on the applicator and then go back and even it out with no finish on the same type of applicator. I lathered it on there pretty good and then went back and wiped up any excess. Overall, this is a very easy finish to apply, and as the name suggests, it only requires one coat. It's definitely pricey, but I'd give an appendage to reduce finishing time, so it was money well spent as far as I'm concerned. Once the finish cured, I proceeded to the final assembly steps. First, I reattached the drawer slides. I then attached the drawer fronts by first drilling out the holes for the drawer pulls. I then clamped a straight edge in place to align the bottoms, spaced out the fronts and clamped them in place, and then temporarily attached the fronts to the boxes with a couple of screws. I then removed the drawers and permanently attached them with some 1 1/4" screws. The temporary screws were then removed and the poles were attached. We're now at the part of the project for which I've been waiting so long with anticipation, attaching the stainless steel top. I got the top from a local metal fabricator. It was designed to just slip over the front and be secured with some adhesive, which the fabricator recommended. The test fit was perfect, and I really don't even think it needed the adhesive. I also had the owner of the potting bench apply caulking where the stainless top met the backsplash. I didn't do this step in the shop because the bench was going to travel a few hours and I didn't want the hutch attached for transport. The final step in this project before it was to go to its home was to reattach all of the slats. And now, the big reveal of the stainless steel top and completed project. Well, in a fitting end, I have somehow lost this last bit of footage. But I do have pictures, and honestly, when it was all said and done, this thing turned out quite awesome. And all of the mistakes and missteps along the way made me appreciate it even more. I removed the hutch and packed it into a trailer, and it made the 3-hour journey westward to my friend's house. Here it is in its final resting place. Thank you so much for watching this video. Plans are available for this potting bench if you're interested, and you can find the link in the description. Also in the description, you will find links to all the tools and hardware used on this project. For those that have stuck around to the end of the video, you will enjoy 50% off the plans by using the coupon code POLYGLUESUCKS. If this is your first time here and you enjoyed the video, mistakes and all, please consider liking, subscribing, and hitting that little bell icon so you'll be notified when I publish new videos.